All right, so we're going to look at graphing another equation, and notice this one has something different going on in that we have a multiple angle here. So since we know trig functions of angles, I'm going to make sure that I get 3 theta to be equal to the magic angles, the 0, the pi over 2, the pi, the 3 pi over 2, and 2 pi, increments of 90. So with that said, we'll backtrack because what we're looking for then is I want to know what theta values correspond to these r values here. So if 3 theta is equal to 0, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. Okay, so if 3 theta is equal to 0, that corresponds to theta equals 0. If 3 theta is equal to pi over 2, that corresponds to an actual theta of pi over 6. And so on. So I'm just going to be dividing each one of those angles that's given there by 3. So in doing so, this is where we are. So we get theta up to 2 pi over 3. We'll see if that's enough. We might have to go a little bit further. So if r is equal to 4 sine 3 theta, I'm just going to multiply everything in this column by 4. So it's going to be 0, 4, 0, negative 4, 0. So let's see where we're at. So at theta equals 0, we're at r equals 0, which means, yep, the origin. For theta equals pi over 6, we are at 4. So that means we have 1, 2, 3, 4. And then for theta equals pi over 3, we are back to 0. Now let's try to figure out what's happening in between there. So we know how the sine function is. It starts at 0, it goes up to its max, and then comes back down to 0. So that means that r is increasing until we get to 4, and then it's decreasing again until we get back down to 0. So then what happens after that? Well, let's see. So if we get to, okay, so theta equals pi over 2, we're at negative 4. So that means I want to face this way, but I'm going the opposite direction. So that means 1, 2, 3, 4. And that means we're going that way, okay? Because we started here, we followed along here, we're going this way, this is the direction that theta is moving. Okay, so now we're there. Now it appears that we have more to go because we didn't arrive back at our starting point. So let's see what happens. So I'm going to keep adding multiples of pi over 2 until we get to the end here. So I'm going to say 5 pi over 2, I'm going to say 3 pi, 7 pi over 2, and let's see how we do when we get up to 4 pi. So that means this is going to keep cycling back and forth. So 1, 0, negative 1, 0. There we go. And then the r values would be 4, 0, negative 4, 0. Okay, so what are the actual values of theta? Well, again, divide all of those by 3. So we have 5 pi over 6. We have pi. We have 7 pi over 6. And we have 4 pi over 3. This is getting complicated here, huh? So, okay, so we left off here. No, we did not leave off there. We left off at here. All right. Oh, we didn't really finish. So 2 pi over 3, r is 0, which means we end up back here, which means we had to make our way back up this way. Okay. Because, you know, as my theta is increasing, my r's are negative, which means I'm still on the opposite side. All right, so now what happens after that? So we got out to 5 pi over 6 for an angle of 4, which is right here. So again, keeping it going. And then we're back to 0 at pi. So then the curious thing that happens after that is, you notice the trajectory is kind of taking it to, just kind of starting back to where we were. So let's just look at this. So at 4 pi over 3, I'm sorry, that's not where we were. At 7 pi over 2, we're supposed to be at negative 4. 7 pi over 2, I'm sorry, 7 pi over 6 is here. So I want to face this way, but I'm going backwards 4 units. Well, guess what? We're tracing back over the curve again. So that means this curve is traced out, theta going from 0 to pi. Okay? And this is what's called a petal curve or a rose curve. So r equals a, and cosine would look the same way. But you notice we have 3 petals. In fact, there is a summary posted in Canvas for you that tells you that if the number in front of theta is odd, that's how many petals you're going to get. And we're going to discover what happens when we get to an even number in front of theta. It might not be what you expect. So that's our graph and some other things that we know about it. Sine theta, how can I tell? Well, you notice that one of the petals is centered around the y-axis. Y is the sine, so that means, yeah, that kind of makes sense. So that's a petal curve, and again, that's graphing, and of course, try this in Desmos as well. So thank you for watching. Stay tuned. I want to go.